In this video, we won't just convert between image formats, but we'll also see, compare, and understand what actually changes when we convert from one file format to another format. So let's explore this topic and understand what happens. So basically, different image type is used for different applications. Like grayscale images is used in medical imaging, then indexed images are common in web icons and maps. Then RGB is very essential for photography and displaying. Right now you are seeing me on this YouTube. So thanks to RGB image type. And then binary is used for OCRs and object detection. So in short, knowing which image type to use and why to use, that can boost your efficiency and your output. And that is what we are going to understand in this video. So in step 1, let's load our basic image once and then we'll use it for all the conversions. So here we have started with RGB image. It's a 3-channel image that stores red, green and blue information. And this is the original image, paper.png. So now we are going to do all these experiments with this paper.png image. So now we'll explore each conversion step by step. So first of all, let's convert this RGB image into grayscale image. So using this RGB to gray, we are converting RGB image to a grayscale image. And this is just a subplot to see both the image side by side. So now let's run and observe. So this is our original RGB image and it is the grayscale image. Now let's see what changes when we convert this RGB to grayscale image. Let's see here whose RGB image and grayscale image. Here you will see that RGB is 3D matrix which has height, width and cross 3, which is for R, Y and B, while grayscale is 2D matrix which saves a lot of memory. This makes a grayscale image ideal for machine learning and age detection. Right now I am telling you only 2 examples, okay? So when memory saving is important, you must go with the grayscale image. Now we'll convert this grayscale image again back to RGB image. Now that's a tough task, but here what this cat command does, it combines all the 3 channel R, G and B together and creates a 3-channel RGB image. Then here we are subplotting the image to observe it side by side. Now let's run this section. Here you can see both the image which looks identical. This one is our original image and this one is the converted RGB image. Now here in this RGB image, each of the R, G and B channel has identical grayscale values. It will result in true color image that looks same as grayscale, but now it is in 3D. Now let's see its property. This is our grayscale image which has only width and height. But this is our converted RGB image which has width, height as well as 3 layers of R, G and B. Now the question is, if both the images looks identical, then what's the purpose of this conversion? So the answer is, you can use this when the function requires RGB input like color overlays or some deep learning models, right? So when the function that you are using that requires RGB image, over there you need to do this type of conversion. So after this we are going to explore another conversion, and that is RGB to indexed image. Now here this line RGB to IND, this is the function which converts RGB image into indexed image. And when you store anything to indexed image, it stores 2 things. One thing is each pixel stores as indexed in this, and the another one is color map. The detail of color map will be stored in this. Let's run this thing. Now here you can see indexed image from RGB. Now if I'll show you the RGB image and indexed image without title, you won't be able to differentiate it, but MATLAB will. And how? What's the difference indexed image creates over here? Now let's see that. Here we'll see the properties of indexed image and RGB. Now see here, you will quickly notice a drop in memory size and a simpler structure. The memory of RGB image is quite high, whereas the memory usage of indexed image is quite less. And still it shows full color image to us. So that's the advantage of indexed image. Now we'll convert this indexed image back to RGB image. So here this is the command ind to RGB. It will convert this indexed image into RGB image. If we run this section, then in visuals you won't be able to find any difference, right? But the difference will be clear when you observe the properties. So this is the function to convert index to RGB. Now we are going to convert the indexed image into grayscale image. So this is the command which converts indexed image into grayscale image. Here you need to remember that whenever you are dealing with indexed image, you need to give two things. One is pixel indexing and the another one is color map of each pixel. So here you need to add two things, and all these details will be stored in this variable. This is the output of grayscale from indexed image. Now here you need to understand one thing. The color map used in indexed image will be converted into brightness level when you convert it into grayscale image. So color map will be converted to the brightness level. Here you can see only grayscale image, right? So the brightness of pixel changes and it will create all the visual effect that we see on the screen. So this type of conversion is useful when you need simplified images for processing, like feature detection. So for that it's useful. Now from this again back, if we want to convert grayscale image to indexed image, then this is the command which converts grayscale image to indexed image. Here we are giving pixel information and then the brightness level. Now let's run this thing. Now this is indexed image which is converted from grayscale image. Here the image still looks gray, but behind the scene it's now stored using indices and a grayscale color map. Let me show you that. See, this is our grayscale image and this is the pixel indexing of our indexed image, and this is color map, or we can say gray color map of our image. So now this image is being converted into index type image. It does not looks colorful, but the image storing format is now converted into indexed image. So here you need to clear this thing in your mind, that whenever we are converting RGB from gray or indexed from gray, it does not look colorful, but the way it is stored in MATLAB, that has been converted. So that's how you can convert several image formats in MATLAB. Now I'm going to tell you some common mistakes one does when they are dealing with this image conversion. The first is forgetting to use map when using the indexed conversion. And second, not verifying image size or class after conversion. And this is very important. And to check those details, you can use whose, size and class command after every steps of valid conversion. So if you have understood image conversion and enjoyed this video, then like it, subscribe to this channel and leave a comment if you have any doubt related to this. So if you want to learn more about MATLAB, you can refer this playlist. So see you into the next video. Till that time, bye bye.